when we started on lesson 2.1 and then 2.2, we talked about arithmetic sequences on lesson 2.1, and then we compared them to linear functions on lesson 2.2. What I want you to remember is that for an arithmetic sequence, our formula was AN equals AK plus D, where D is a common difference, times N minus K. That was your arithmetic sequence formula. Now this was that was your arithmetic. When we got to lesson 2.2, I said, hey, this is very similar to a linear function. In linear, we say the equation is y equals m x minus x1 plus y1. Now, if you really compare them closely, you'll see that both of them have some value multiplying a parenthesis. So the common difference and the slope are similar. These values are similar, the common difference and the slope. And then the y1 and the ak are similar. You can see how these values correspond to one another. That's how the relationship between these. Last thing, I didn't put that here, where your common difference, it's equal to taking any value from a sequence and subtracting the one that came before it. Taking any value of the sequence and subtracting the one that came before it. So whatever n is, whatever two values they give you, if n is 10, then this would be n minus 1, this would be a9. If you took a sub 10 and you subtracted a sub 9, you'd get your common difference. Okay, so I'll put that. Those were your two formulas that we had on that. Now, let's come on down here. Last thing, actually. Do you remember what's the difference, graphically speaking, between a sequence and a function? What's the difference between the sequence and a function? Do you remember? Okay, I'll tell you. A function is continuous, like this. Function is continuous, whereas the sequence itself is discrete data. It would be discrete, where that just means a bunch of dots along the line. So this one's discrete. This one is discrete. That just means a bunch of dots, whereas the linear function is continuous. That's the difference in them. In real world, things you count are discrete. Things that are measured are continuous. That's the difference. If it was a real world, if it were countable things, you'd say it's a sequence, discrete. If it's not countable, if it's measured, then it's continuous. Okay, finally, let's go to geometric. So in geometric, our formula was G sub n equals, do you remember? Without me telling you, do you remember what it was? Okay, times r to the power of n minus k, where r, so instead of having a common difference, we have a common ratio. It's where you take any term and you divide by the one that came before it. How is this similar to exponential? With exponential, the formula I gave you was y equals y1 times your base raised to the power of x minus x1. Once again, you can see that values correspond to one another. Your base and your common ratio, they correspond to each other. The GK and the Y1, they correspond to each other. You can see these values correspond. Okay, questions about those formulas? Just know your formulas. A lot of the problems, if you know your formula, are basic to solve. I'm going to use those formulas throughout the rest of this front slide. We're going to work through, I think it's just 3 problems. We'll use these formulas to help us as we go. All right, so let's try this first one. It says, determine the equation or rule for the following sequence. We have 3, 12, 48, 192. My question for you, it says it's a sequence. It says it's a sequence. Is this arithmetic or geometric? Geometric, good. How'd you know it's geometric? Because you see it's not adding by the same amount. It's like we would add 9 here, but this is not adding 9 there. So it's not arithmetic, so it's got to be geometric. If you want to find the ratio, the common ratio, Randy tells me it's 4. What you do is you take any term and you divide it by the one that came before it. So if I took 3 and 12, what is 12 divided by 3? 4. That's your common ratio. So I'm going to call this G1 here. This is G2. This would be G3, G4, and so on. If I use my formula, Gn equals Gk, which you can say, I'm going to, on this one, say my Gk is going to be equal to G1, which is, G1 is 3. It'll be 3 times 4 to the power of n minus, what's my k right here, just to be clear? K is 1, good. So it'd be n minus 1. That's where that comes from. That would be my formula right there. That's it. Just to be clear, mathematically, that is equivalent to, you could have plugged in a 12 right here and had a 12 but an n minus 2. Or you could have put a 48, n minus 3. Or you could have put 192 right there, n minus 4, and it would have worked. So all those formulas would have worked. That's just using exponential, manipulating your exponential functions by properties. Okay, how about the next one? It tells us this sequence is arithmetic. A3 is here, A32 is 228. So let's start this. Since I can't find a common difference, since they're not next to each other, I better use the formula from the get-go. What was my formula again? AN, AK, D times, there you go. Okay, that's your formula. What we're going to do here is to solve this, I'm going to start by saying AK is A3, and what is A3? Now if I do that, that means K is what value? 3, good. What I'm also going to have to do, since I don't know my common difference, is I'm going to have to say this is AN. I'm going to say for a moment AN is A32, which is 228. If A sub n is equal to A sub 32, that means n itself is going to be 32. So if we substitute these values in, we should be able to solve for a common difference. So instead of AN, what am I substituting for AN? What's the mathematical value? Nope. 228. 228 goes there. What's the mathematical value for AK? 25. We don't know D. That's what I need to solve for. I do know N. What am I substituting for N? And for K? 3. Now we can work through this and solve it. We're solving for our common difference here. I'm going to follow PEMDAS parentheses first. What is 32 minus 3? So 228 would equal 25 plus, you said that's 29. I'm going to rewrite this as 29D. How would you solve from there? Subtract 25 from both sides? So when I subtract 25 from both sides, 228 minus 25 is 203. So 203 would equal 29D. Arlene, I see you have a computer open. Do you happen to have a calculator available? Could you type in, sorry, I'm getting a step ahead. What do we do to get D isolated here? Divide, that's multiplying. Can you take 203 and divide that by 29? I'm guessing that's 7, but I'm not for sure. 203 divided by 29, it's 7? Okay, so if our common difference is 7, I'd like to say that's our answer. That's not the answer. This problem says determine the equation Now I can solve my equation. You plug it back in where you do not substitute an and n. So what I'm going to do is I'll take that to write my equation. I'm going to say it's an. This time I'm just going to, this was like a temporary value over here. The an is like your y, and n is like your x. So this is temporary what I did right there. What I'm going to do now is a general equation to solve for any n value no matter what. So it'd be an equals, what did we say ak was? 25 plus, what's our common difference? 7 times n minus 3. You could leave it like that. You could actually simplify if you wanted to. I'm kind of doing extra now. What could I do with this 7 in the parentheses? You distribute. You could say it's an equals 25 plus 7n minus 21. And you could actually combine those like terms and end up with the equation an equals, I'm going to put the n first. I like n first. 7n, what's 25 minus 21? 4. You could simplify this equation all the way to there if you wanted to. It's kind of the same idea on the previous problem when I told you you could do exponential properties, change this around if you wanted to. Like you could, when you have an exponent that's subtracting, you could, if you remember, divide the base. So you could just divide this by 4 to the power of 1 and get rid of that if you like. So those are things you don't have to do. I'll just write what I just said. You could rewrite this using the quotient property. Using the quotient property, what you could do is say that this is 3 divided by 4 to the first power times, whoops, forgot the 4, to the power of n. You could rewrite it this way. What is 4 to the first? Actually, I don't want anybody to get confused. I'm going to rewrite it one more time. Sorry. 4 to the first is just 4. You could rewrite it that way, and that you could finally rewrite as 3/4 times 4 to the power of n. You could write your equation that way if you wanted to. You could write it like that if you desired. So just to let you know, there's different ways you can write an equation, but as long as they're mathematically equal, you're good to go. Any questions on that? Okay, I'm going to do one more of this type before we move on to the next topic. So these were topics 2.1 and 2.2. We are testing over 2.1 through 2.8. So the front side is the first 2 lessons. All right. Determine the equation or rule for the following sequence characteristics. So this one doesn't tell us what type. It says A0 is 2, A2 is 1.28, A4 is this. What do you think, arithmetic or geometric? Are they subtracting the same amount each time? Is it subtracting the same amount?
No.
No. If it's not subtracting the same amount, then it must be a geometric sequence. It must be multiplying by some amount. Once again, since we don't know what we're multiplying by, and since these aren't back-to-back, I cannot discover what the ratio is because these numbers aren't back-to-back. What I'd have to do is use my formula. Gn equals gk times the ratio to the power of n minus k. So let's pick some points here. On this problem, what do you want to say gk is? I'm going to say it's this A0 there, which means that gk is equal to A0. A0 is 2, and k will be, what is k in our problem? 0. Good. I also have to find a gn. This is going to be temporary again. So gn is typically like your y, but to solve this, I'm going to have to do this. Gn can be either the other two. I'm going to just use A2. Gn will be A2, which is 1.28. Don't panic about me switching from this letter A to a G. G stands for geometric. A usually stands for arithmetic, but here it's just the sequence is given with the letter A. Okay, and let me put down n is 2. So if we substitute n, we can solve here. Gn. What are we substituting for Gn? 1.28 equals GK 2 times R to the power of, what's n? Minus, what's k? 0. To solve this problem, what's the opposite of multiplication? Divide. We divide both sides by 2. Anybody know what 1.28 divided by 2 is without a calculator? 0.64 is correct. 0.64 equals R to the power of, what's 2 minus 0? 2. Okay. 0.64 equals R squared. What's the opposite of a square? Square root. Square root. So technically, anytime you add a square root, you should add positive or negative anytime. I'm not going to stress over that, but do y'all know what the square root of positive 64 is? Square root of positive just 64. 8. Do you know what the square root of 0.64 is? 8. So technically it's did I say 8? Sorry, I meant to say 0.8. It could be the positive version, it could be the negative version. They don't tell us here, so I'm just going to go with the positive. Alright, I'm just going to go for the positive, the formula. Once you have this, we can plug in our values. You return Gn. So I'm no longer working with these temporary values. So I'm just going to say Gn equals, what was our GK again? 2 times the base of 0.8. I'll just do it in parentheses here so it doesn't get lost in the multiplication symbol. To the power of n minus 0. Do I need to put n minus 0? Just put n. Because it's n minus 0. That's our formula right there. All right.